So a question came up as to, is it okay to use fuses in parallel? Well, let's take a look at it. So what I have here is a circuit, and I have this 309 milliohms. This is the load. We're talking about a lot of current here, and the only way to get a lot of current out of a 6-volt source is to have a very, very small resistance, almost a short. But that's how we're going to get the current requirements that we need. In this case, it's going to be around 19.4 amps. So if we had fuses, the fuses in themselves are 6.3 amps apiece. So the thought is like, well, if I have 6, then I put in 2 and I got 12, and I put in 3 and I got 18, and I put in 4, and like, yeah, we should be good, right? We should be good because between the current, it's going to go evenly through each of them. And mathematically, that makes sense. So let's take a look at this. I'm going to go ahead and open all of these, or I should say close the contacts. And here we go. We have 4.85 amps running across each of them. Now you'll notice there's a resistor here, and the reason being, there is going to be some type of resistance across any type of mechanical connection, right? So surface area, whatnot, unless maybe it's soldered or welded together. But in this case, fuses typically have some type of a contact point on it. These are set at a minuscule amount of resistance, which is 0.001 ohms, which is next to nothing. So we're looking at this and like, all right, well, everything seems to be working fine until one of them blows for whatever reason. And now what happens? Okay, across the 3 that are left, I have 6.47 amps. Well, if they're only rated by 6.3, then this one's going to pop. Now I'm at 9.69 apiece. This one's going to pop. And then I'm at 19.4, the whole current, and this one's going to pop. So now I have zero flow, and there's no current. And you're like, okay, well, that's not a problem as long as one of them doesn't pop. Okay, you'd think that, but let me show you why this is such a big deal. Let's just say I have this resistor, and the value is, it's 1 milliohm, so 0.001 ohm. Let's bring that up to 2. So we're going to double it, but the amount of resistance, even though it's double, is still negligible. Now I'm looking at it, I'm like, ooh, wow, I just barely changed that, and now I'm at 2.77 amps. And the other ones have picked up, now they're at 5.54 amps. So that was a pretty dramatic increase, but you know what? It's still within the design value, not a problem. Well, let's go to this one. Let's do the same thing with this. I'm just going to go ahead and I'm going to bring this one up to 2 milliohms. Now look what we got. I have 2 of them that are running at 3.23 amps and 2 of them that are running at 6.47 amps, which is it's above the design value. So what'll happen is one of these two is going to pop first, so this one's going to open. And now at which point I have these other two are at 4.85, that's fine, but this one up on the top, now that's 9.6 amps. Clip. Now the other ones are at 9.6, so this one will pop. This one will pop. And at which point our circuit's dead. Under no circumstances would you design a system this way. In perfect application where you have a brand new system, you might be able to get away with this. But as soon as there is any slight change, even if I turn this back down to 1 milliohm and turn this one up to 3, suppose it got hot, let's go up to 4. Oh, we're getting close. Let's go up to 10. We're right on the edge. So we go back a little bit more, bring this up to, say, 20. Now we've popped all 3 of them, and we go into the same cascading failure mode. So the other thing that I could do, let's just say that this thing actually just went to 1 ohm. Just 1 ohm. Now you can see that we're going to pop it. 1 ohm. It takes nothing to get to 1 ohm as far as any type of these contacts. You wouldn't design it this way.